All right, good morning. This video is for Thursday. We're doing the second part of our problems for math. We're gonna do problems 17 through 29 here on the video, and then you'll be working on the even numbers and then answering those questions on the quiz. So please make sure you're doing that. Please make sure you're doing the work. And again, if you have any questions about the even number problems, just go ahead and leave a comment. I'm going to be explaining a couple of them, or one of them on the board with you guys here. So let's jump right in. Problem number 17, we have 2 1/2 divided by 1/3. So I've set up my problem here, 2 1/2 divided by 1/3. And I've done a couple of things here. So I've set up my multiplication signs showing me that I need to change this mixed number into an improper fraction. Second thing I've done, I've written a 1 underneath the whole number 3 to show me the whole number in its fraction form. And this is going to be important in a minute. So in order to change the improper fraction, in order to change the mixed number into an improper fraction, I'm going to multiply 2 times 2, which gives me 4. And then I'm going to add 4 and 1, which gives me 5. So 2 times 2 plus 1 equals 5. And the denominator remains the same, so I have 5 over 2. Now, I can't divide this fraction, so I need to change it into a multiplication problem or multiplication operation. So I changed my sign into a multiplication. But now, I'm not going to multiply it by 3 over 1. I need to multiply it by 1 over 3. And that's why I set up the whole number with the 1 underneath, to show me what its fraction form or what its reciprocal is going to be. So the reciprocal of 3 is 1 over 3. So now I have 5 over 2 times 1 over 3. When multiplying fractions, we multiply both the numerator with the numerator and the denominator with the denominator. So in this case, 5 times 1 equals 5, and 2 times 3 equals 6. 5 6 can't be reduced any further, so that is your final answer, 5 over 6. Next, let's go on to number 19. We're writing the following number in decimal form. So it's written out in scientific notation. So you have 5 times 10 plus 6 times 1 plus 3 times 1 over 1 100th. Okay? So 9 times 10 represents that the 9, or tells us that the 9 is going to be in the tens place. And then the 6 times 1 tells us that the 6 is going to be in the ones place. So 6 is in the ones place, 9 is in the tens place. Then we have our decimal. Okay? We don't have any information about the tens place, which would be represented as whatever number times 1/10. So we hold that place value with a 0. So we write 0, and then we are given information about the hundredths place, which is represented by 3 times 1 in 100. So your final answer should be this, 96.03. And that's how you would write it in, write the decimal number of the standard notation. All right, on to number 21. Okay, you're given a set of numbers, -2, 0.2, 1, and 1/2. Okay, which of these numbers is closest to 0? So to kind of give you a visual idea of what we're looking at, I put the 2 in the negatives place right there, and put the 0 sort of in the middle, okay, because you have a -1 here. Okay, we're not given that information. But you see here, I've written out a number line so you can see the distance from 0. So our 0 we placed in the center. Okay, our half is in the halfway point between 0 and 1. And then 0.2 appears to be the closest one, and in fact is the closest one. So your choice out of these 4 numbers would be 0.2. Now, you're given 1/2 in fraction form. If you were to take 1 divided by 2, you would get the decimal number 0.50, which is represented as 0.5. So 1/2 represented as a decimal is 0.5, and that's how I got that 0.5 right there. Okay? But your final answer to number 21, the number that is closest to 0, is 0.2. All right, next, number 23. The 4th power of 2, which is 2 to the 4th power, equals 16. What number does the 4th power of 3 equal? So 3 to the 4th power is represented like this. The 4 is the exponent, the 3 is the base. Make sure you You remember that, okay? That's why I'm repeating it, okay? 3 to the 4th power can be represented as 3 times 3 times 3 times 3, okay? Which gives us 3 times 3 is 9, so now I take 9 times 3 is 27, and then 27 times 3 is 81, okay? So 3 to the 4th power equals 81. Your final answer would be 81. And now to this one right here. To what decimal number is the arrow pointing? Again, I set up the number line here for you to see it. You can look at it on your book right now. Important thing to do when you get a problem like this, count the tick marks between the whole numbers. In this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, which makes the whole. So there's 10 tick marks between the 10 and the 11, okay? So now these are gonna be your decimals. These are gonna be your decimal places. So this is 10, this is 10, this is 10.1, 10.2, 10.3, 10.4, 5, 6, 7, 8, 9, 10, until you get to 11. So this represented as a decimal would be 10, I write it down here, 10.2. That should be your final answer for problem number 25, 10.2. All right, number 27, where did I put it? Oh, here it is. Oh, you guys like that? I drew that myself. It's pretty cool. I didn't have to draw all this. I should have worked it out in my head before I drew out this whole extra part. Anyway, I'll explain as we go. The coordinates of the vertices of a quadrilateral are 0.5, not 0.5, negative 5, 5. So the x is in the negative 5. Actually, we'll just plot it out as we go. Okay, so if you still have graph paper, again, use front and back of your graph paper. If you haven't gotten any, try to draw something like this. Do the best you can. I gave you a bit of several pieces of graph paper, but I'm not sure if it's enough. If you don't have enough, try to draw your own graph, like I did here on the board. And if you do have graph paper, go ahead and plot out your lines. So you have your x axis and your y axis, and then create a grid, like so. If you notice, right there, this represents the center of the x and the y, so this is my 0. So everything I'm counting from this point. Our first vertices is set up at negative 5, 5. So I'm gonna go this way, towards my negative numbers. So 1, 2, 3, 4, 5. I went over 5 places towards the negative on the x-axis, and then we have a positive 5. So I'm gonna go up, 1, 2, 3, 4, 5. So I plot my point right there. This point represents negative 5, 5. Then I go on to my next one, 1. So I count over 1 place to the right, which represents my positive number, so 1. I go over 1, and then the y is on 5. So I go 1, 2, 3, 4, 5. And I plot my point, 1, 5. The 1 is in the x-axis, and the 5 is in the y-axis. All right, so you should have these 2 points plotted. At any point in the video, you can pause it if you don't understand it, or if you need some more help, just go ahead and comment on the video. Next, we have 3, 1. So I count over 3 places, 1, 2, 3. So that represents my x-axis. Oh, I'm sorry, I went the wrong way. Let's go with positive 3. I went the wrong way. So positive 3 is 1, 2, 3. I move 3 places over to the right, which represents my positive numbers on the x-axis. And then I go 1 place up, which is one positive number towards the y-axis. So I plot my next point, 3, 1. Now I can do my last one, which is negative 3, 1. So I count from the 0, 1, 2, 3, and I'm going towards the negative numbers. And then I go 1 place up, because that's a positive. The y is in the positive number, okay? And then I connect my vertices together. So what is the name of this kind of quadrilateral? What is the name of this kind of quadrilateral? So you can look back and you can see that this quadrilateral that we just formed here on our coordinate plane is a parallelogram. It's got 2 parallel lines, okay? So go ahead and write that. Your final answer should be the graph of this problem. So you should have all 4 points graphed out. and your final answer should be a parallelogram. I didn't write down. I'll go ahead and write. Parallelogram. I think I spelled it right. Did I? I did. All right. Final answer to number 27 is parallelogram. All right. On to number 29. So 29 is part of a two-part problem, and I'll read the whole problem right now. In this figure, a square and a regular hexagon share a common side. The area of the square is 100 square centimeters. Use this information to answer the problem. Okay, so what I did is, this is problem number 28. I should probably write that down somewhere. This is problem number 28. This is part of problem 28. I'm not going to give you all of it, just the part that you need to understand right now. So first we need to find the length of each side of the square. Okay, so the area of this square is given to us as 100. The way we find area is A equals length times width. Area equals length times width. So in order to determine this, we need to find two equal numbers that when multiplied together equal 100. Now, if I took 4 times 25, I would get 100. But that would be, the length of one side would be 4 inches or centimeters or whatever, and the other side would be 25. So I can't do that because the square has all 4 equal sides. But if I do 10 times 10, that gives me 100, okay? So the way I determined the length of my square is I found two even numbers that I can multiply to give me the final answer, which in this case is 10. Now, in the hexagon shares a side with the square. So if the hexagon shares one side with the square and the side of each of these squares is it centimeters? Yes, is 10 centimeters, then we know that the length of each side of the hexagon is 10 centimeters, okay? A hexagon has 6 equal sides. So the first part, part of the answer for 29A is 10 centimeters, okay? Because they're all equal sides, the perimeter of the hexagon, we just have to add all 6 sides together. Now, I didn't draw out the hexagon for you guys, I just realized that. But a hexagon has 6 sides, so you just add all 6 sides together, which gives you the final answer of 60 centimeters, okay? And that's it for today. Great job. Thank you for paying attention. I hope you did pay attention. If you have any questions about any of the video, you can always rewind, fast forward, pause, and most importantly, leave a comment on the video if you have any questions at all, and I'll get back to you as soon as I can. All right, guys, thanks.